And we got the recording going. That's good. So this is called testing 1, 2, 3. So what are we learning today? It's kind of obvious, but we are learning unit testing in Java. Exciting, right? We're also going to be learning about the JUnit library specifically. We don't have to use the JUnit library when testing in Java, but in this course, and honestly, many people will use JUnit. It's kind of popular. Another really good reason to focus or attempt to focus during this lecture is that the graded assignment number 2, like this lecture is basically all about graded assignment number 2. So I went through that earlier this week because I want to be a little bit more, I want to have the graded assignments a little bit more in recent memory so I can be a little bit, so I can tie the lecture better to the assignments, if that makes sense. And so working through assignment 2, it feels like it's split in half, where the first half you are setting up a class, and then in the second half you're writing tests. In my personal experience, it is like a very, like 20, in my case, I was like 20% of the time was setting up the class, and then like 80% of the time was like writing the tests. So just as an early warning for time management, it's not 50-50, it's more like it's really heavy on the unit testing side of things. So that's why we're going to learn about unit tests today. I'm sure for a lot of us, our heads are probably still thinking about graded assignment 1, but this will be really helpful for the near future. Right, so we talked about unit tests with JavaScript. We worked with Jest quite a bit. We had a graded assignment where we wrote a lot of tests. And so I'm curious how y'all would answer the question of why write unit tests at all. So this is very open-ended. So anyone and everyone, curious to hear your thoughts. Yes. Makes sure that your code still works after you refactor. That's what you said? Okay, that's a very, very valid reason. A scenario I find myself in professionally quite a bit is as a project grows, maybe there'll be like a new requirement, and it could be something simple like, oh, we need to rename this one thing because the language was confusing. You know, naming things is hard in coding. It's a huge part of it, and so you go through your application and you change like 30 files. You change what this thing is named. Now, in changing those 30 files, the likelihood that someone like myself may have made a mistake and broken something is pretty high. And so to be able to just push a button and run unit tests and just to check, hey, did I break anything? Nope, we're still good. Then press forward. And so that's a very good example of why unit tests is like, well, when you're refactoring, you have some confidence that at least the critical parts of your code are still working. Cool. Any other thoughts? Any other thoughts? Yes.
Makes it a bit more readable for other people interacting with code.
Okay, that's an interesting thought. So it makes it more readable for other people interacting with the code. I can see that, like, if you were to read the tests, is that what you're suggesting?
Yeah, it gives a good idea of how the code is meant to run.
Sure. Yeah, that's definitely, that's a good example. So you could read the test and see like, okay, how is this method supposed to be called? What data are they passing into this method when they call the method? So all of those things can be helpful, right? But one last one. Does anyone else have thoughts? Yes?
Just making sure that your app runs how you designed it to.
Right. So you're talking about like as you're writing the tests? Yes. So just making sure your app runs how you intended to. And so as you're writing tests, you can prove that things are in fact working how you want it to. It's so easy to make assumptions as developers that like, oh yeah, I'm assuming that these 9 pieces in the chain are all functioning as they should, and once we get down to this last piece, it's going to work. It's easy to make those kind of assumptions, but yeah, writing tests can help us incrementally rule out assumptions in our code. Cool. Thanks for sharing. Let's move on. Here's just a slide. This is how I think about unit tests personally, is that if you have a small project, the effort it takes to write unit tests and to set up the unit testing library feels like more work than the benefit it provides. And so I believe that as a project grows, so does the importance of unit testing. As the complexity scales, so does the necessity of things to manage complexity, like unit testing. So this next section is not so much about how you must write tests, but this is more a strategy on how to think about testing or how to approach testing. So 3 steps for unit tests. All right, so there is a thought process that we will arrange, then we'll act, and then we'll assert. So arrange would be setting up the context. So let's say, for example, we want to test a class. When we arrange the test, that means we got to import the class, we got to create a new instance of the class, we got to get everything set up before we can actually do anything. Now, acting would be like if we called the method on a class. And so that's doing an action. And then assert, we could assert that, did this action produce the output that I thought it would? So this is just sort of a way to break up tests. A non-coding loose example would be like pick up a cordless drill, attach a drill bit, and you pull the trigger. If anyone's used a cordless drill before, it's like really tempting to pull the trigger just to see if the batteries are working. And so if you know, you know. And so the action is pulling the trigger on the cordless drill. And then what we're expecting to happen is that when we pull the trigger, the drill spins, the drill bit spins. Now, if that test fails, it could be for a number of reasons. It could be that the drill's broken. It could be that the batteries are out. We're not worrying about those. We're just trying to test, does this work when I do the actions I expect? So arrange, set up the cordless drill, attach the battery, etc. Act, pull the trigger. Assert, did it do the function it's supposed to? Now, a coding example, let's say you made a custom math class with a bunch of methods that add, subtract, multiply, etc. Arrange, you'd import your math class, you would create a new instance of it, etc., whatever you need to do to set it up. Act, you would call the add method. And then assert, you would say, okay, when I pass in 1 and 1 to the add method, I am going to assert that it should be a 2. Right, so it's worth mentioning, and we'll go through this flow again, but it's worth mentioning that this pattern is well suited for testing methods and functions. Sometimes we test other things, like just, is my class set up right? And we'll address that in a minute here as well. So JUnit. Everything you need to know about JUnit. JUnit's logo looks like it was designed by the creators of the 2003 Christmas comedy Elf. That's all I got. Just kidding. I think y'all know me well enough to know that that's not the end. So introduction to JUnit. It is the most popular Java testing framework, so it makes sense that that's the one we're learning. It's relatively easy to use, and it is similar to Jasmine, which is what we use in Jasmine is what we use in Unit 1 with JavaScript. So here is a side-by-side example of a JUnit unit test and a Jasmine unit test. You'll notice that the syntax, there's definitely some broad differences in the syntax, but in actually what the pieces of syntax represent is basically the same. So in Jasmine, we'll start with what we know first. All of our tests are typically structured inside a describe statement. And so, or a describe function right here. And then we can add each of our tests inside of it. And we know it's a test because it starts with the word it. And so it reads something like it tests the method or something like that. And then inside of our individual test, right here, we are arranging some data, and then we are making an assertion on that data. This is a very, I don't know, the example is so reduced that's kind of pointless as far as this particular test. But to compare it to what we have over here on the other side with JUnit, we have all of our tests are inside a class. No surprise there. Working with Java, we have to have it in a class. We know it's a test because we have the test annotation right here. And so this is the name of our test method as opposed to this over here. We're just calling the test, like the method's name is the test's name. And then inside of it, the insides look extremely similar. I mean, once we have like the general setup of like the class and the test shell, the inside, like the actual testing part, is very, very similar. So here we see an example where we are arranging, setting up the context. We create this new string variable, and then we do assert equals, and we say, does hello equal string? And this could be even made more similar if we were to use like assert true, and we could do something like hello equals string or something like that. And then that would, we'll look at assert true later. So to break down unit tests a bit more, we'll look at the anatomy of a JUnit test. As mentioned a bit ago, so we have a class. We have to have that set up. Of course, we need to import JUnit, and we'll need the supporting files inside of our project, etc. And so now we have our test class. Looks like a normal Java class. Inside it, we'll add our first test. You can right-click and generate a test, and it will generate something that looks very much like this. But here, we're just going to write it in. So we say @test, saying this next method is a test. And then the name of the test is the name of the method. And then our test content is going to go inside the test. So using the assemble or arrange action and assert, here would be an example test. So here we create a new doggo from the doggo class. And then the action is we use the set name setter, pass in Fido. And then the assertion is we say the text Fido should equal doggo.getName. And so in this flow, we are testing that we can create the class. We're testing that we can set the name, and we're testing that we can get the name. We're doing all of that all at once, but yeah, cool. So the other side of this is where I've been talking about, like the saying assemble, maybe assemble is a better word, like the assemble, act, assert, a type of a framework, set up the context, do an action, and then make an assertion on it. A lot of times we don't need to do the act step. So oftentimes we can just assemble the code and then just test it. And so when we get to, the reason why I'm mentioning this is when we get to graded assignment 2, there will be a lot of tests where you are assembling it and then you're just testing it. You're making an assertion on it. You don't necessarily need to do that middle step of like doing an action if we're just thinking in that flow. So in this example, we set up the context, we created a new instance of the doggo class, and we passed in Fido, and that just gets passed into this constructor. So now the field equals Fido, and so now we test. Do we set the field correctly? And this test is essentially, the assertion portion is the exact same in both cases. We just skipped the action. So I think this would be a good place to pause for questions. Did this bring up any questions for you? Any thoughts? Anything you'd like to share? No? Pretty quiet. Okay. So this section of the slide deck I also added in very specifically because I thought this would be useful when we approach graded assignment 2. Right. So we have this concept of mock data. And so here, hopefully that's visible enough. I'm actually going to make this a bit bigger real quick. So I feel like I want this to be seen. Cool. So here we have a test with the @test annotation. The name is test toString contains correct data. Maybe there's a better name for the test. I'll keep working on that. So we first set up the context for the test. We create a new instance of the doggo class. We pass in Sherlock. So we have a new doggo named Sherlock. The next thing I do here in this test is I create a string. And inside the string, I've got this string that's basically on one line, it's going to be ID 1, and then the next line is going to have name, and then the name Sherlock. Then I got these new line characters. And so what I'm setting up here is I'm setting up what I am expecting testjob.toString to output. And so then I compare testjob.toString to my mock data, which is my, well, that doesn't say mock data. Sorry, I make these and then I refactor them, and then sometimes I have mistakes like that. Right. So here we're able to test that testjob.toString in fact equals mock data. And this is very useful to do it this way, because if you're to try to put this giant string, especially if there was like 5 or 6 lines, if we were to try to put all of that inside of our assert equals, that would get really messy and get really hard to manage. And so to have just a mock data variable that you're comparing to an output, very, very useful in my opinion. Now, here comes another critical takeaway, in my opinion. Ideally, when we mock data, we would actually want the mock data to be hard-coded. And so this is a different mindset than we have when we're normally programming. I feel like at this point, we all have a sense that hard-coding data is a bad thing. We don't want to hard-code data. We want to keep things dynamic. But when it comes to a test, we want to keep things very black and white. And so in this case, in this slide right here, mock data, it's hard-coded. It is a very fixed value. And so ideally with mock data, we would hard code the data, but it's totally okay if we get values programmatically if needed. And so in this example for mock data, we get the doggo ID programmatically. Oops. Sorry for the real-time edits. All right, cool. So we get the ID programmatically. And so there's a lot of reasons why we might want to get the ID programmatically. If you think about how we've set IDs in the past, they're a static field. And so what I have seen in the past is the more tests you add to your test suite, the more this ID field gets incremented. So for example, if you create 5 instances of doggo across a bunch of tests, the doggo ID is going to increment with each one. And so if I were to write my test where I say, I know ID is going to be 1, and then here I write another test, my ID might now be 2 or 3 or something else. And so that's not very good for testing. And so this is a really good takeaway I'd like you all to at least remember for the future. Is that ideally we'll hard code it, but if that's not practical, we can just dynamically get the data. Cool. So, questions on this slide? Yes. Correct. I'm definitely realizing in real time how many mistakes are in this this particular slide deck. Right. Thank you. Other questions or edits to my slide. Happy with both.
So I'm just kind of curious if there's a static member being updated. I'm wondering how that coincides with the scope of that test. I'm kind of used to variables kind of existing within that.
Right, of course.
And so is that like something that's just kind of good form to do in that scenario, or is that something where the static variable will supersede the scope of that function?
Right, and so I think your question is partially why this is easy to get tripped up over. And so the question was like, okay, in the past when writing unit tests, I'm very used to everything being contained in that unit test. I don't have to worry about my variables bleeding over into other unit tests. And so the question was, okay, is this static variable, is that you're basically asking if that stays the same between unit tests, or does it reset or anything like that? And the answer is no. It does not reset, and instead it continues to increment. So here's a way to think about it. All of the instance fields, meaning all of the fields that only exist when we create an instance of the class. So if you create like a private field that's not static, that's like an instance variable. And so an example of an instance field or an instance variable would be like the doggo's name, Sherlock. And so Sherlock has a name, Sherlock, that's part of the instance, okay? And so Sherlock does not exist. That name field does not exist until we create a new instance of it. And so if we create 10 instances of the doggo class, we can have 10 unique name fields. We have Sherlock, Bonsai, Fido, all the others. However, while these instance fields, they only exist when we create an instance of the class, a static field that gets created when the class is loaded into memory. So when we press run on our Java program and it loads up the program, that static field exists. None of the individual instance fields exist, but that static field exists. And so that means if we have 10 tests, and each test increments that static ID variable, it never gets reset because it's loaded initially, and then once we close the app down, then it gets deleted from memory, etc. So that's a bit of a long-winded explanation. Hopefully that wasn't more confusing than helpful. Does that make sense? Do you have follow-up questions to that?
No, that was
Cool.
exactly what I was looking for.
Sweet, awesome. Yeah, thanks for the question. Yeah. Cool. Other thoughts, questions, anything over here? Yes.
So does that mean that your test will never really get in the way of your code because you won't be running like the code at the same time you're running the test?
So does that mean that our test will never get in the way of our code? Yes, and that's yes. So when we run our test suite, that's in isolation from running our app. And so yeah, we don't have to worry about incrementing the ID field, and then when we run our app, it's like, oh, our ID field's already at 12. Why isn't it at 0? Yeah, so that's a great call out. We don't have to worry about those two things running into each other because you can consider your test suite almost like its own application, and then your application as its own application. They get run separately. Cool. Thanks for the question. Yes.
So, do you ever do your arranging and acting outside your test field, like at the top and you do a bunch of tests later, that will reference your ranges and your acts? Do you separate those at any given point, or is it for each test you create some stuff that does something and you test it?
All right. Great question. So the question was, when we create a test, or when we create an entire test suite, do we always do our arranging, setting up the new class, the new instance of Doggo, all these different things? Do we always do that for every test, or do we do them sometimes outside of the individual unit test? So there are two answers to this question. The first answer is, in my opinion, I am totally okay with tests not being dry, meaning I'm totally okay if we are repeating code a bunch in our tests. That's valid, and I'm happy with that. Tests are not the place to over optimize and be too dynamic. We want things to be very this compared to this kind of a thing. And so that's one answer. The other answer is that a little bit later in this lecture, we are going to talk about the before each annotation, the after each annotation. I think there's a before all and after all. And we could use something like before each to maybe to create a new instance of the doggo class. If we're doing it in all of our tests, we could refactor our tests and pull that out into the before each. And so then we would be doing our arranging per se in the before each section of our tests. And so yes, there's ways to refactor it, but I'm happy with either. Yeah. Cool. Other questions? Cool. Great questions. Good discussion. I appreciate it. Let's move forward. Oh, yeah. One more thing. You may have run into this, or this might be obvious to you, but I wanted to call this out. Professionally, when writing tests in any framework or language, it is, in my opinion, very helpful. I should say, in my experience, it's been very helpful just to compare what the output of the test is versus what I'm expecting the output to be. And so when you look at the terminal, the console output for JUnit, you will see this blue link that says click to see difference. And so we can use that to say, that can be so helpful. So imagine, for example, in the test, I think this one, yeah. So in this test, where we are trying to compare what we think the toString output should be versus what the toString output actually is, when we're trying to compare those two things, well, the difference that could be causing the test to fail could be as simple as I have an extra space, right? Java don't care. It's gonna fail the test. But if we click to see the differences, it will show us, hey, in this spot, there's an extra space here. It might not be super obvious in how it points it out, but it will try to highlight it. It'll do its best. And that can save so much time. Like, why is this test failing? Just try to compare the difference to the output. It's a very, very useful way to approach it. So yeah, just another quick tip. So JUnit test annotations. We alluded to this during question time. So we have a few test annotations. We have @test, that's annotation. Of course, we've seen this. This is every unit test needs to say @test at the top. That's how we know that the method is in fact a test. And then we have the before, and so this is going to happen before all of our tests. Then we have the after. This is going to happen after all of our tests. So for @test, we kind of already covered this. I don't want to belabor that. So before and after. So these are used to run a block of code before each test or after each test. And so this, in some cases, you can use this to help keep your tests isolated to a certain degree. And so an example for this is a bad example, but let's say that we had a static setter for our ID field. We probably do not want a static setter for our ID field, but if we had one in our before tests, we could reset the ID to 0 before each test. And so then that way we wouldn't have to worry about the ID like changing the more tests we write. It would just be reset to 0 each time. And so one way to think about before is we can use it to refactor our test, pull repetition out of it, and we can also use it to help eliminate things where like, oh, every time I create a new instance of this class, it's incrementing this field, stuff like that, if that makes any sense. And then after is basically used the same way, it's just when it happens. Right. Okay, so here's an interesting example. Let me see if I can catch my brain up with this real quick. So we have outside of the tests, we're creating a new doggo instance of doggo. Doggo's name is Buddy. And this is probably not a good strategy to do it like this, but this developer just chose to do it right here, to create this context right here outside of the tests. And so in the first test, we say test get name. And then the string says we're going to expect the name to be Buddy. And then we're expecting that the name is Buddy. That's fine. This seems very valid. We're just testing that when we're just testing that the doggo's name was Buddy. This next test, we test the setter, the ability to set the name. And so we take this existing doggo class and we say doggo.setName, and we're setting it to max. And then we're expecting that the doggo's new name is Max. So these two tests, they're going to pass just fine, right? But what happens if we switch the order of these two tests? Any volunteers? Oh, yes. The second test will fail. Yes. That is because before all the tests, we created our doggo called Buddy. And then if we switch the orders, then we're setting the doggo's name to Max. But in the next test, we're expecting that the doggo's name is Buddy, right? And so now we've got an issue of our tests they're messing with each other. They're causing each other to fail. So this is an example of the opposite of best practices. So this would be a poor practice. So here's an example of how to mitigate that issue without needing to create a new doggo instance for each class. So here we expect the name to be Buddy. It is Buddy. Here we set the name to Max, and the doggo's name is Max. And even if we switch the order of the tests, it's going to rerun this block of code before each test. So for test 1, it runs this block of code. For test 2, it runs this block of code. And so in that way, we don't have to worry about those kind of issues bleeding into other tests. So yeah, this would be a great example of how to use before and why to use before, one of the whys. Cool. So before we move on to the next section, any questions while we're here? This is a lot to, in my opinion, this is a lot to process, just understanding testing. At least in my experience, that's what I found. Writing code's one thing, testing code's another. So, yeah. Cool, moving forward, assertions. JUnit has several. They're very similar to expect statements in Jasmine. So we can have assert equals, assert true, assert false, assert null, assert not null, assert not equals. We're probably going to be using the top two 90% of the time, in my opinion. So here is an example of assert equals versus assert true. I think this will be useful, especially as we're writing tests in the future. So here we have our expected output. We're essentially saying we expect that 2 plus 3 equals 5. And so we put our expected output on one side and our actual output on the other side. And it doesn't matter which order they're in because you're comparing if they're equal or not. And so here we have test true. And so test true, we could just put the entire equation in there. We could say test true that 5 equals 2 plus 3. So these tests are testing the same thing. But this one, assert true, is testing a condition. Does whatever is inside of these set of these brackets, I guess is what we'll call them, parentheses, language is hard. So whatever's inside of these right here, it's going to be true or false. It's going to evaluate to true or false. And that is going to determine if the test passes or if the test fails. And then up here, we'll determine does A equal B. And that will determine if the test passes or fails. Right, so here's a good question. This is also a bit of a callback to last lesson. What happens if you use an assert equals on two different objects with the same properties and values? So just describe a scenario. We create two instances of the doggo class. We call both doggos bonsai. Yeah, bonsai and bonsai. And so if we run a test where we're asserting equals, does bonsai 1 equal bonsai 2? What's going to happen? Is the test going to pass? The test going to fail? Yes? Yes. Great answer. So it will fail, even though it feels like it should pass, because the objects look the same, but they're located at different places in memory. And so therefore, object A is not the same as object B, and therefore the test will fail. So follow-up bonus question to this: how could we modify the doggo class so that when we run a test, like does bonsai A equal bonsai B, that will actually pass and that'll be true? How can we modify the class so that when comparing two different objects with the same properties and values, it will return true? Yes? I'm sorry, what was that? Well, we could assert that bonsai A.toString equals bonsai B.toString. That's definitely a valid option. But if we weren't going to call the toString method and we were just passing the objects themselves, bonsai A and bonsai B, or bonsai A or bonsai B, there's something else we could do. Yes? Override equals? Correct. And then when we override equals, there's one more method that we typically override, which might be hash. Yes. Yes. So we override equals and the hash method together typically. Cool. And so then that would be how we could do that. And that's just a callback to last class when we were looking at overriding the equals method. Right. So I'm going to pull up IntelliJ and we are going to write some tests. Okay. Hey, I remembered. Sweet. So this is our main class, and here we have two instances of the doggo class. We have name and then the dog breed, and we have bonsai and Sherlock, and we set bonsai's best friend is Sherlock, if you remember that part of the lesson. And we can do different things like print out who bonsai's best friend is. So I think we use this as an example. Oops, I'm running the wrong thing. Let's run main here. So when we run this, we get Sherlock. Okay, so this is not super relevant. Just getting a feel for how this program is set up. We can look at the doggo class. We have the whole next ID paradigm in here. So we've got like the static ID that no matter how many instances of the doggo class we create, it's not going to affect this variable, except for right here when we increment it. We have all of our fields. These are all things that should look familiar compared to other classes we've worked with. And so now we have a test suite. And in here, I'm importing JUnit. I'm importing the assert statements. And then I'm importing the doggo class. And so here we have our first test. And I wouldn't call this a dumb test, but because this is valid, I'm going to rename this to test structure. I think it's ER. Cool. So if we run this test, it passes. But what we want to do is we want to write a test to verify the dog IDs are incrementing, write a test to verify that the dogs can't have friends, write a test to test the values of the doggo class's species constant. So this class has a constant field right here. We learned about those. That's when we combine static plus final is the term constant. It doesn't say constant, it's just a concept. And then we'll test the breed value, and then we'll refactor using the for, assuming we have time. So let's start with the first new test. We'll start with the @test annotation. I'm gonna make this larger because there's no need not to. @test, and then public void because it doesn't return anything, and then we'll say test IDs are incrementing. Cool. So here I'm going to create my strategy to test that the IDs are incrementing is this. I'm going to create for my arrange or assemble arrange. I'm going to create two different doggos, doggo A and doggo B. I don't really care that their names are the same. I could change them if I wanted to, but my strategy is I'll create two doggos, and then I'm just going to compare, are the IDs the same? And I want them not to be the same. I'm not going to go through the trouble of trying to say, is doggo A's ID 1 and doggo B's ID 2? Because that could be a bit faulty, because if I add more tests, their IDs might not be 2 and 3 anymore, or 1 and 2 anymore. And so I'm just going to say, are their IDs different? And to me, that's going to be good enough to call this good. So let's say integer ID A equals doggo A dot get ID. ID B equals cool. Arrange and assert. We don't need really an act phase for this. We're going to assert not equals. We're going to assert that ID A does not equal ID B. And I could go a bit further here, and I could say assert true. And I'm going to assert that ID B is greater than ID A. Okay, and so this is going to tell me two things. The first assert statement, if the IDs are not incrementing, if they're not changing, then the test is going to fail right here. If the IDs are changing with each doggo, but they're going in a different direction than I expect them to, then this one will fail. So let's run this, see if it passes. Cool, it passed. So I have a decent amount of confidence that my ID incrementing code is intact. We'll write the next test, but I think this is a good test to pause on for questions. So any questions, thoughts on this? Yes? Oh, test 1 of 1? Oh, why did that happen? Great call out. Thank you. So test 2 pass. Right. So this is actually a good moment to mention something else in testing. Is if you've never seen your test fail, you might need to double check your test. And so in my case, I just made a quick assumption that, oh, my test passed. I had a decent amount of confidence in the code I had written. But a good way to say, like, is this test doing what I think it's doing, is just to switch something. And I'm going to expect this to fail, and so I'm going to run this again, and it fails. So seeing a test fail can be really useful to know that your test is passing how you expect it to pass. Cool. All right. Thank you for that call out. Any other things to call out or any questions? Yes.
Was there a reason that you chose to make the integers like non-primitive? Does assert not equals take objects only as its parameters?
I didn't think about it that far. We can see what happens if I do it like this. It doesn't mind. As long as I guess in this case, as long as they're the same. I will say for myself, and I'm not like a Java veteran, so they might have a strong opinion on this topic, but for myself, I generally will just default to the object type because they can be used in more contexts. So that's how I roll, but yeah, it's probably a more in-depth reason to choose one or the other that I don't think through when I write Java, if that makes sense. Cool, great call out, great question. We'll just leave it like that. Cool. Other questions? Yes.
I assume that both of the assert statements need to be true in order for the test to pass.
Correct. Yes. So we can have as many assert statements in our test as we want, but if any of them fail, the entire test fails. Yes. It's a great call out. So I can go assert true, put false in there, and now I've made my entire test fail. And so that introduces a good heuristic on how to break up our tests. So let's say we have assert statements that are asserting, we have one test, but it's really testing like two different parts of the code. Maybe we want to break that up into two tests so that when it fails, just the test name itself will give us an idea of which part broke. So if I find myself, with a bunch of assert statements and I start realizing, okay, this is testing two different parts of the code, just split it up into two different tests. Yeah. So great question. Yes.
Do tests have access to every part of the class?
Do tests have access to every part of the class? So tests have the same amount of access as if you imported the class in your regular code. So if you have let's say you have a private field that does not have a getter, your test cannot access it. So it's going to play by the same rules. Yeah, great question. Yeah, now in my own brain, I could see myself wishing that, okay, maybe my test could have special privileges where I could reset that static ID field to 0 each time without needing a setter for that. If it was that way, that would be less ideal because then your test world doesn't match your real world. So ideally, your test world and your real world should behave the same way. And so we can expect our classes to have the same rules as far as getters and setters and access and stuff. Yeah, great question. Cool. Yeah, really great questions this evening, just as a whole. Any other questions while we're here? Cool. Let's write the next test. Write a test to verify that dogs can have friends. This is an important one. Test. We will call this, needs to be public, void because it doesn't return anything. And then we can say dogs can have friends. Okay, so we're going to have to do some setup for this test. I'm going to copy this, have doggo A and B again. I want to make this one a bit more specific. So I'm going to call this one bonsai and then this will be listed for short. And then for doggo, so this is going to be, so this is arrange right here. Range assemble, and now I'm going to act. I'm going to do an action, which is going to be doggo A dot set best friend doggo B. Now I'm going to assert that assert equals, I could do assert equals or assert true, and I'm going to say doggo A dot get best friend is the same as doggo B. Now I don't have to worry here about having any special override methods for the equals, because when we set doggo A's best friend, we're setting a reference to memory. It's not like a copy of the object. It's actually, we're actually referencing that exact specific object. And so I don't have to worry about overwriting anything here. This should pass. This does pass. And I can just, as a sanity check, test that this is working how I expect it to. So I'm going to comment out my act step. And this should fail because I never set the best friend. And this does fail. Okay, so that's a good sanity check. Undo that, run it again, and we're golden. Cool. This is a pretty good example test. Any thoughts on this or questions? No? Okay. Cool. Right. I'm going to skip these two, and I'm going to go straight to the refactor. Had before. Actually, I forget exactly what the syntax is. I'm just going to call this before. I don't know if it has anything else special going on here. It doesn't like that. Annotations are not allowed here. Let me try to remember. Jump back to the public void setup. That's all. I was overthinking it. Cool. So here, I'm going to, because we keep referencing doggo A and doggo B, I'm just going to move these two dogs into the before. Okay? And then I'm going to get rid of this line and just make a slight modification, just call it doggo A. Here, I don't need to make any modifications. I think. It's not going to let me do this. I thought it would. That's a good idea. Yeah, thank you so much. Great call out. And to explain what just happened there, it was a scoping issue. So I created these inside of the scope of the before statement, and so it wasn't available outside of that scope. And so what I did here, per the comment, is I initialized the variables outside of the before statement, and then I set the variables inside of the before statement, so that now each time in these tests reference doggo A and B, they have access to the scope, and then they have also a new version of it because it gets set before each test. Let me go ahead and scroll down through here and see that everything else looks good. We don't need this anymore. All right, let's run the suite and see if it works. Three failed. Null pointer exception. I may have a wrong assumption on how to use this before statement. I feel like I had a good idea. Let's see here. Jump to Google real quick. Setting. Mm-hmm.
I don't think you need the doggo in your before statement. You've got doggo and then doggo A. You already. I don't think you need that. I think you can just do doggo A and
Nice. Excellent. Yeah, this is great. I love the help. Cool. So we dropped the declaring the type, and that allowed this to work correctly. Thank you so much. Cool. So I just ran the test again. They're all passing, and so now we've successfully refactored our code to declare the doggos before each test instead of each test. So with that, we're at 6:28. Take one more question, and then we'll break for studio. All right, that's it. Good luck on studio, and we'll be back here at 8 for